All right, so we are ready to calculate some inverses and actually determine what the functions are. So we've done graphs of inverses. We have done checking to see if two things are inverses, and now we're actually going to find inverse functions. So I'm going to show you two different ways. One is the operations method, which is conceptual. It's really an analysis of the operations you're doing to the function. The other one's a more traditional algebraic way. All right, so let's start with the operations. The operations way is an analysis of what is happening to the input. All right, and we remember that an inverse function undoes the operations and in the reverse order. Okay, so we'll see that in this example. All right, so the first thing I do is I list out what's happening to the x. Okay, so the first thing that happens when I input x into this function is I subtract 4. And for this example, I'll even write that happening as it goes, right? So I literally take x and subtract 4, right? Then my next step is I square root, right? That's literally like if I plugged in, the number 8, I would subtract 4, then I would take the square root of my result, and my last step would be multiply by 5, right? So I'd end up with this. That is, those are the operations in the correct order for f of x, right? Subtract 4, square root, multiply by 5. So when you do the inverse, we need to do inverse operations in reverse order. Okay, so the last thing I did for f of x was multiply by 5. That becomes the first thing I do for the inverse. But instead of multiplying, I'm going to divide by 5. Right? So I have an x, right? My input, divide by 5. Okay? The next thing I'm going to do is square. Right? So I take this and I square it. Right? The final thing I do is I add 4. So from this one right here, subtracting 4, I'm going to take this and now add 4. So we see that these operations build this function up. Now it's very important that we do it in the correct order. Otherwise, you might have the 4 in with those parentheses. What we're doing to x is we're dividing it by 5, squaring what we have, then taking everything we have and adding 4 at the end. Right? Now, very important, and we'll mention this on this one too, but it's very important that we consider the domain and range for each function, okay? This is going to potentially add a restriction on to the inverse, right? I like to think about this as there's a restriction here that is really talking about the domain. But if we think about the domain of f of x, right, we know that it can only accept numbers greater than or equal to 4, right? That's almost implicit in this function here is that numbers less than 4 will not work. 4 is the smallest number that can be plugged in to f of x, the smallest input. We also know that the only things that can come out of the square root function there are positives, right? Or 0, right? We can get 0 or positives, can't get any negatives. So what that tells me, right? I know my range should be 4 to infinity, right? I also know my domain should be 0 to infinity, right? What I do there is while I build my inverse function, right? I'm going to write my inverse function over here, and I'm going to leave a little space for it. I'll white that out so I have space. My inverse function is x over 5 squared plus 4, where x is greater than or equal to 0, right? So this restriction came from this fact, right? That's the only thing that I can plug into this function, even though it doesn't have that. It came from f of x, right? So it must have, right, that relationship where the domain of f of x becomes the range, and the range of f of x becomes the domain of the inverse, right? So I must include that restriction onto the inverse. Otherwise, that's not truly the inverse, right? In other words, that's what makes this the inverse of f of x and not just a function that is not actually the inverse, right? So let's try it the old, we know what the answer is. Let's try it the old school algebraic way. So this way says, you know what we're really doing here is just flip-flopping the x's and y's. So a lot of times we see this as f of x, but it's really y equals. So we're going to write it as a y to start, right? Then we switch the x and the y, right? So I literally, in this equation, I write the x as y and the y as x, right? The input is the output is the input, right? But what we're going to do is solve for our new y, right? Now I want to make the connection between this method and our traditional method. The first thing you would do here to solve for y is, well, you divide by 5, right? You'd want to get rid of that 5, right? Which happens to be the first thing we did over here, right? Then we square each side, right? So we have x over 5 squared equals, now that undoes the square root part. So we squared each side, and then the last step would be to add 4. So it actually is the inverse operations in the reverse order to solve for your new y. Now the one thing you must do, you have to rewrite the function as f inverse of x, right? And we also have to figure out what the domain would be. And it still is going to be x has to be greater than or equal to 0. Right? And again, that comes from the range of the original being 0 to infinity. Right? Okay. Let's try a couple. All right. So let's do a couple. Sometimes they give you a restriction right from the beginning, right? Hopefully that makes sense why that restriction is there. X squared plus 6 does not have an inverse. It's not 1-to-1. But if we allow for just the positives and 0, all of a sudden we can do an inverse, okay? So what we're saying here too is we actually have the domain, right? So operations-wise, what we're doing is we are squaring, right? So we're taking that, and then we add 6, right? Inverse-wise, we subtract 6, and then square root, right? Those are the inverse operations in the reverse order. Now, we had this x is greater than 0 from here, right? So I have to ask myself, okay, the domain must be 0 to infinity, right? I like to use interval notation for this. It's just easier, right? But it really means the same thing as that, right? Now we also know, and this is really important, the range is, right? If I look at x squared plus 6, the smallest that this could be is 6, right? When I square anything and add 6 to it, the very smallest is going to be a 6. Okay? Now, if I build my inverse function as the square root of x minus 6, right? it is sort of implicit that all we can take are values greater than 6, but that should make a lot of sense coming from our range, right? The domain now is 6 to infinity, and the range is 0 to infinity, right? So what I've got here is x is greater than or equal to 6, right, as the domain. Okay. Algebraic, we can do the same thing real quick. We'll make it y equals x squared plus 6. We switch our x and y's. And subtract 6. All right. Now technically, right, when we take the square root here, we could get plus or minus square root of x minus 6, right? We have to ask ourselves, if the x values are greater than 0, right, that means the y values have to be greater than or equal to 0 in the inverse, right? So we're only going to take the positives here, right? So f inverse equals x minus 6. That has to match up with the fact that our range is 0 to infinity, right? And again, it's that buy one, get one free relationship that we can use for that as well. Okay. So I would state x has to be greater than or equal to 6 as the restriction there. But that's also implied as we go. Okay. All right, we'll try 2 more, and then I'll let you guys practice. All right, so operations-wise, right? Oops, yeah, let's use red. Operations-wise, we've got 5x plus 9. So we build that with, I need to rewrite it there. We build that by adding 9 first, right, in parentheses. So x plus 9, and then we multiply by 5. So it becomes 5 times x plus 9. Inverse-wise, right, we are going to divide by 5. Right, so we take our x over 5 and subtract 9. Okay. Now here's the beautiful thing about this one. If we look at this closely, I mean, we also could write this as 5x plus 45, right? No matter how we look at this is definitely a line, right? And we know that lines that are not vertical or horizontal have a domain and range that's negative infinity to infinity, right? Which also means there are no restrictions on the inverse at all, right? The domain is still negative infinity to infinity. Okay. Now, if I want to solve this algebraically, the good old-fashioned way, again, hopefully we're seeing the connection. This basically tells us the order in which we can do operations to isolate our new y, right? We can divide by 5, and we can subtract 9. Now, you could distribute this from the beginning, and then it would be multiplied by 5 and add 45. That would result in the same thing. You would just have, x minus 45, the whole thing over 5, which is totally fine. Okay, but then we just write it as our inverse, and there's no restrictions at all. Okay, we get the same thing either way. There's our inverse. All right, last one, and then you guys will try the rest. Okay, this one's a little bit funny, right? First of all, look what's given to us. We are given these two things. Now, these two things are super important. X is greater than negative 3. Well, that's a restriction. It's also the domain. f of x greater than 0, well, that's like a y value, right? That's actually the range, right? So we know that the domain and the range of f of x are that, right? -3 to infinity and 0 to infinity. So if we list out the operations here, I ask myself, what do I do as a very first thing to x? Well, I add 3 to it, right? Right. So adding 3 becomes x plus 3. Then I square. So I do that. Then what I really do is I take the reciprocal. Right? So after I do, like, if I plugged in 2, I would do 2 plus 3 is 5. I would square it and get 25. Then I would put the whole thing over its reciprocal, right? So when we build our inverse, hopefully it should make sense that the reciprocal of something, right? If we keep taking its reciprocal, right? Not that these equal each other. What I mean is that if you take the reciprocal of 1 over x, you get back x, right? And if you take the reciprocal again, you get that. Take the reciprocal, you get that, right? It's just really flipping 1 over x and x over 1. So taking the reciprocal of something is its own inverse, right? So when I build this, the first thing I'm going to do is take the reciprocal, right? It's its own inverse function, so that becomes 1 over x. Then I square root. Then I subtract 3. Okay, but I must make sure that I include what the restriction is on this, right? Now we know this becomes the domain, so 0 to infinity, and we know that becomes the range, -3 to infinity, right? So when I write this, I want to use this to write the restriction on the domain. X is greater than or equal to, not equal to, in this case, x is greater than 0, right? Okay, and again, that's important, right? It's almost, it's implied in this function in a way, but because we can't plug a negative under the square root and 1 over any negative number would be negative, but we want to write it, okay? Algebraic, let's do that real quick. Get x equals 1 over y plus 3 squared. Now, what we would actually do here, right? You can think about it as over 1 if you want. You can multiply each side by y plus 3 squared. But you'd still end up dividing by x, right? Equals 1 over x. Now we can do that because x can't be 0, right? So we're okay doing that. Just making sure we can actually do that, right? Y plus 3 equals, now technically this is plus or minus square root of 1 over x, but we look back, right? When we solve, we're like, okay, wait, the range has to be greater than or greater than -3. So we know we must take the positive again for that. So we have f inverse x equals square root of 1 minus x minus 3. And we know x has to be greater than 0. All right. Okay, go ahead and try some of the others, or try all the others on this page, right? Try them both ways, okay? It's good to get practice in both ways, and then we'll head to